My name is Torsten Hoefler from ETH Zurich, and we are here at the SC15 conference, which is slowly winding down. It has been one of the most successful conferences of the SC series, at least in terms of numbers of attendees, and it has been highly exciting to be here the whole week, essentially. But now we are looking forward to what's happening in next year in HPC, and with that, I want to introduce our guest here, David Keyes from Coast, who will tell us a little bit about next year's happenings.
Well, before SC16, we have a highlight coming up June 8th through 10, 2016 in Lausanne at the campus of EPFL, namely the Swiss Platform for Advanced Scientific Computing Conference, which will be the next in the ACM series of HPC conferences with ACM Quality Refereeing and ACM Prestige Archiving. And at this meeting, we look for a mixture interdisciplinary of leading-edge applications who share in common HPC enabling technologies. So whether it's chemistry or geophysics, we're looking for emphases on, for instance, domain-specific languages, programming models. We're looking for implementation techniques. We're looking for heterogeneous architecture performance. And these technologies in common, with people speaking to each other from many different disciplines, will, we hope, create a very enriching meeting.
Oh, wonderful! So you've been at the same conference last year, and you've given a wonderful keynote, telling everybody how we should look at algorithms differently for the exascale era. So, what were your major impressions last year, and how do you think this will develop for next year?
Well, it was my first PASC conference, and I was very excited by the quality and by the diversity of science. I sat in on a number of application talks that I wasn't a contributor for in the resume sense, but learned a lot about how they are using enabling technologies, particularly new algorithms that I care a lot about.
So what are these major trends in the new algorithms that you care about? I mean, what are you seeing as going towards exascale? Can you briefly summarize basically what you learned between last year's keynote and today? Maybe did something change, or are we moving into a direction that you pointed out and you see the community moving towards there, and at PASC there will be 10 papers on that particular topic?
Well, it's hard to measure on a 6-month window because everything tends to blend together, but I would say that my greatest enjoyment of this conference was the unanimity of people converging around some of the pillars of algorithmic transformation that just have to occur. A relaxation of global synchrony, greater SIMT-style concurrency, even if it means doing more flops, having greater arithmetic intensity to overcome the memory bandwidth limitations that almost everybody at this conference is universally feeling, and the interesting new subject of trying to convince architects the vendors in particular, that they are allowed to give us less reliable hardware in search of energy efficiency, because we are capable on the application side, on the algorithm side, of handling much better lack of reliability, either in performance rate or in the actual computations and storing of numbers themselves. So the attention to algorithmic resilience at this conference has been really very gratifying. It doesn't sound like the SCs that our mothers went to, so to speak.
Yeah, wonderful. I mean, this is actually one of the major goals of PASC, to bring together the vendors, so the hardware architects, the computer scientists and mathematicians who work on algorithms and implementations, and of course also the application scientists who use the computer at the end. So this cross-cutting approach is it's a very important concept in that context. So how do you see the importance of that developing, also in the context of supercomputing? So meaning, how are these people working together, hand in hand, to achieve the goal of exascale? So we could talk about Codesign or something like this.
Codesign is really shaking up, I think, the communities, because we are, the hallowed principle of computer science has been separation of concerns, where, each group gets to write to a pre-agreed upon interface and can operate efficiently within their own domain, and that may leave a lot of performance on the table or a lot of energy efficiency on the table. So forcing each part of the community to think about the problem that the other side has is one of the main exciting themes, I think, in high-performance computing today. We are not a collection of communities, each with a specialization, like a collection of academic departments, but we are organized around trying to solve real problems that are pertaining to sustainable human society, and that may require a great mix within a single group. And one of, I think, the challenges is how can we amortize expertise in common across many of these applications. I think this is the SIDAC model in the US, the SPP-EXA model in Germany, the PASC model in Switzerland. There are many programs whose acronyms I don't remember in Japan and China, but we're all realizing that we can't solve every problem with a whole swarm of computer scientists and mathematicians, but have to look for the right abstractions that nevertheless succeed in mapping over many different heterogeneous architectures.
Oh, so wonderful. These are actually lots of topics that our watchers and listeners may want to submit papers for to the PASC papers track, which is the first in the history of PASC, so to say. And as you mentioned at the very beginning, it's an ACM quality and sponsored reviewed track, and we encourage everybody to submit a paper by early January. So thank you very much, David, for the nice interview, and see you at PASC this year, next year.
See you in Lausanne, June 8th through 10, Torsten. Thank you.
Okay. Thank you.
Bye-bye.